gathered here today to conduct this fluid statics experiment. We're going to be immersing this apple, this here apple, in water in order to find the weight. So here it goes, nothing. Alright, so as you can see now, it's at 750 milliliters. Alright, what I'm planning to do is I'm planning to drop this very slowly here, just to be very safe, because this is dangerous water right here, it can drown. So, as you can see, it is displaced by about 210 milliliters. So this should be enough to calculate the weight force, which is equal to the buoyancy force. Now let me explain why this is true. Notice how I said this is a fluid statics experiment. It's static because the apple is not moving at all. So since the apple is immersed in water, it's displacing some volume of water, but it's not moving anywhere. There's no dynamic motion or dynamic energy, going on. You know that there are two vertical forces. There are two body forces. Let me be politically correct. There's two body forces. The two body forces present are buoyancy force, FB. Here, come closer. And weight force, FW. All right. So these are two body forces, and let's just write down what we usually do in physics 1. F net is equal to 0, right? So what are the F nets right here? So sorry, what are the forces present? So you got the buoyancy force upward, and you got the weight force downwards. Negative is because we chose upwards to be positive, and this is equal to 0 because there is no acceleration. So FB is equal to FW. And you know that the buoyancy force is equal to gamma volume displaced. Alright? So gamma is going to be of the fluid. So that's gamma of H2O, which is a specific weight. The specific weight of H2O is just about 9,810 what is that? Units for gamma. So we multiply that by the, and this is SI units. We multiply this by the volume displaced, right, which is about 210 milliliters, which is equal to 2.1 times 10 to the negative 4 meters cubed. Once you do that, you get 2.0601 newtons. 2.0601 newtons. Now that's going to be the weight force. Right? The weight force is equal to the buoyancy force. Now, since we are engineers, me and Franklin here.
Oh, here. And here.
And there.
And that Jesse right there.
Alright? Since we're engineers, we like to be very sure of our work. We like to double check, our quizzes, which we barely have enough time to double check, so just putting it out there. It's been said. So turn it on to scale.
Calibrate it.
Calibrate it.
Yes.
Place it. That's 218 grams, which is equivalent to 0.218 kilograms. That's in SI units. Trying to be correct here. So you know that the weight force is equal to mass of your object multiplied by gravity. You know the mass is equal to 0.218 kilograms. You know that gravity is equal to 9.81 meters per second squared. Right? Once you multiply these two, you should be getting 2.1386 newtons. Right? So as you can see, 2.1386 newtons is fairly close to 2.0601 newtons. Now there are sources of error here, and there's a difference in error of about 9%, and Frankie here is going to be explaining this error.
Okay, so what I think about the error is the water that you have here. like when you look at it, we are only eyeballing the volume change. So from that, it might not be as accurate as like a measuring tool. So and the other thing is that even though the apple that we took out of the water to weigh it again, there might be some kind of water that we did not take out or cleaned out. So there might be a discrepancy between the scale's weight, and how we measure it. So that's what I think the error would be. So yes, and that's about it.